Welcome. We're gonna go ahead and get into chapter 4 here, and I'm not gonna get into the PowerPoints for all of it because we're gonna go and have play, of course, and we're gonna get into the I believe it's the bank charges assignment. So I'm gonna go ahead and demo number 10 for you. But we're going to talk about primarily 4.1 relational operators, if statements, and if else statements. 4.4 you can probably handle it on your own, and then we'll get into the main one, which is logical operators with relational operators. That's kind of our main topics for this particular thing. Of course, the switch statement, you guys you can have time on that for yourselves. So 4.1, 4.2, 4.7 are the main impetus for this chapter. And let's go ahead and get started on those items, and then we'll go ahead and demonstrate the use of it, of those particular things as we go through the PowerPoint, of course, when we get to playing with our assignment. So when we talk about relational operators, basically they're special variables or not variables, but they're special operators to be used to relate to operands. And what I mean by that is something like this. If we have, let me go ahead and zoom in on this for you. If we have an integer x equals 3 and an integer y equals 2, we may want to relate those values. And how do we relate them? Well, hey, is one equal to the other? Is one greater than the other? And just like with your normal operators like plus, minus, divide, when you're using relational operators, the data types have to be the same. When you're relating different operands. So when I use the term operand, what I'm talking about is this guy right here. That's an operand. It's what an operator operates on. And so we have an equals operator that is operating on from right to left on the x variable, assigning it equal to 3. That's an assignment operator. So a relational operator is when we want to relate and say something like x greater than 2 or x greater than y. So all that does is say is check to see if x is greater than y, and I believe that probably is. It doesn't really do much other than looks at to see if x is greater than y. What happens when this comparison is done, what is determined, hey, is x greater than y? If it is, then that returns back a 1 being true. So when we talk about true and false, 1 is true, 0 is false. Now, we also use relational operators, primarily use Boolean operators, and we also use the keywords true and false to represent true and false. But essentially what's inside the code for a true is actually the value 1 and false is actually the value 0. So when I use 1 and 0 interchangeably with true and false, just know that 1 means true and then 0 is false when we're dealing with Boolean variables. So what I could do is I could do something like this: cout x greater than y, and what that would output is a well, it looks like it doesn't want to work for me, but what I can do is I can actually assign a Boolean value to this, and I can say bool t equals x greater than y. And what happens is then, hey, x is compared to y. If it is greater than y, then t is going to hold the value true. If x is not greater than y, then t is going to hold the value false. So relational operators do not have to be inside of an if statement. They can be just, out in normal code land. And they can also have what we call the logical operators, which we're going to get into in a little bit. And we're going to actually do debugging today to show you how an if statement works. And what an if statement is the ability to look at a relational operation and decide whether to process some code or not. And that is what we have for making decisions, and we call those control structures. So an if statement is what I call a control structure, and it controls the actual flow of your code. What I mean by that is it is the actual step top-down behavior of your application completing its instructions. And these are the different relational operators that we have. And one thing to note is that equal to, notice how it's using a double equals. It is not to be confused with an assignment statement that just uses an equal. So this is an example of an assignment statement, one single equal. This is an assignment of a relational equals. What that means is, hey, is X equal to Y? Are they the same value? If they are, then T becomes true, or 1, and then if they're not, if X is not equal to Y, then T becomes false, or 0. And primarily what we often see these things in, to begin with, especially while we're learning, is inside of an if statement. And your if statement has two main parts. It has the relational operator that is going to be making a choice on. And then it has the code that is run between the first brace and the closing brace that essentially is run only if the relational operation is true here. And all the if statement cares about is true or false. And that's where we're going to start. So if I put an if 1 in here, basically, or if I do an if true, basically I'm not really looking at to see if anything's true or false. I'm just straight up saying it's true in there, and therefore the code inside of here is going to run. And then we add that with the else statement. But I'm getting ahead of myself. Let's come back to this in a second. Let's get back to our PowerPoint. Okay, so relational expressions, as stated here, we're good with that. Here's an example that I've already kind of shown you. So the if statement. Oh, great. I guess I'm not getting ahead of myself. We already covered those ones. So here is the format of the if statement. So essentially, you're going to have some kind of condition, and that condition is going to be some kind of relational operation where you're looking to see if something's true or false. And then only if that condition is true will the statements inside be actually completed. So let's demonstrate that. And we're going to do that with a little bit of some debugging. So what I'm going to do here is I'm going to say cout yes, and that is only going to happen if this actual value is true. I'm going to set a breakpoint here, and I don't know why this got okay. So I'm going to set a breakpoint here, so we can kind of see what's going on. And what set a breakpoint does is it pauses your process so that you can examine what's going on line by line and see it actually processing. And it's the better way of. Let me just say, if you get a good habit of debugging, you're going to have a social life, at least somewhat of a social life. If not, you're going to be doing the guess and check method and not really learning very well. Number one. And And number 2, taking a lot longer to learn. And then number 3, of course, no social life. So yeah, I'm pretty sure you would want some dates on the weekend or whatnot. So let's look at this debugging thing. So what I'm doing here is I set the breakpoint, and it has to be on a line of runtime code, meaning code that actually does something. Since we're assigning that to 3, it does something. Therefore, it's runtime code. And it'll pause, and I can do step over and whatnot to examine what's going on with that code as it's being processed. So the code starts at the beginning, and it stops and it pauses at a line that has not been processed yet. So right now, line 14, we set the breakpoint at line 14. Line 14 has not actually happened yet. And if we go down here, here's like our debug window right here, this little area down here on the bottom left-hand side. It tells us what local variables that we have that we're currently using. You see that X is popping up there. And as soon as I do a step over, we're going to see that X now has the value 3, but Y has not been set. It's just containing the memory or whatever was in there before. I do a step over, and now Y has been filled. And your locals are, the locals window is pretty much all the variables that you have available within a scope, within 2 braces, 2 open-close braces. And now we look at this if statement, and the if statement's going to evaluate as true because, duh, I've made it true. I've literally typed it in. So the if statement's going to look at that true. And remember, an if statement only cares about true or false. It only cares that it only looks at a true or false of, and if you put a relational expression in there, the relational expression will be, taken care of first, and then the if statement looks at what the relational expression returned. So in this case, we're literally forcing it to be true. So that means that my runtime is going to go into here, and it's going to output yes, because with a control statement or with a control structure, we're controlling the flow of our code. We're manipulating how it behaves top down. So we're saying, hey, is this true? Okay, then let's go ahead and do that. But if it was false, it's going to not do the code in the if statement. So if that comes out as false, see how it just skips right past it and doesn't do anything? That's because the only time this code is run is when that value is true inside. And there's a lot that you can do with debugging, kind of keeping track of your variables as you go, and you're seeing them be processed. A little bit more of a proper way of working with an if statement is to do it with relational expressions. And then we can say, hey, is X greater than Y? And what will happen then is what will be evaluated first is this guy. And is X greater than Y? Well, X is 3 and Y is 2. So yes. So what will be returned to that is a true or a 1. And then the if statement looks at that 1 or 0 and decide, and from that it decides whether to do line 20 or not. So remember that with an if statement and control structures, in fact, all control structures, if statements, loops, whatnot, they all run based on a true or false condition. And we use relational operators to work with conditions. Okay. Now, one other thing is if you only have one line in here, you can just not have these if you want. If you don't have your braces, that means only this one line after your if control or your if heading, only this one line after it will be part of the if statement. And it's just a shortcut sometimes that people use if there's only one thing that they need to do within the if statement or one line of code. But for good practice, don't omit them. Try to put them in for now. Okay. I think we are all good here. Now we get into a little bit more of a discussion on if statements, and that is putting them together. Now I'm going to describe this improperly and then properly, because if statements, it also is important in what order you put your if statements. So for the example with this, for this example, let me kind of give you an idea of what I'm talking about. So we have, let's say that we have a score that we're working with. And we're going to assign that score to 90. And I say, hey, if score is greater than, let's assign the score to, no, let's do it to 60. Let's do it 60. If the score is greater than 60, see out, then that's a D. If score is greater than 80, then let's see out that that's a B. And if score is greater than 90, then we will see out that that is an A. And notice how I'm not putting in the braces for this one. They're all one-liners, so that's okay. But here's kind of where direction really matters when you're working with control structures and the top-down behavior of your program. When I put in a score of 60 here, the only time I want an output is if if my score was greater than 60. Let's test it with 90 and see what happens. Okay, let's see, a score of 90, what my actual output that I would want would be to, let's make it 91, because greater than means greater than. What I'm looking for is for it to output an A. So I'm going to go ahead and keep the breakpoint at the same spot. We're going to walk through this. Okay, so score is 91, and I say here, and it says, hey, score is 60. Or is score greater than 60? If it is, it's a D. Well, then we look at this problem, it's like, well, yeah, 91 is greater than 60. Oops. 91's not a D. And it looks like each one of these is going in, when only one should happen. And so then goes into your other idea of if statements, is because you can solve this problem one of two ways: by using logical operators, which we're going to talk about shortly, or by simply rearranging the order that you are looking at the data in. Now I'm looking at it from the opposite direction, and I am going to set the score to 91, and it should now behave appropriately. Because once it gets here, oh wait, no, it's still going to be a problem, because score is greater than 80, isn't it? And greater than 60. Interesting. That's where the else if comes in. So what you can do then is say, hey, if score is greater than 90, I'll put an A. Otherwise, if it's greater than 80, I'll put a B. Otherwise, it's a D. And the else if, what it does is it only allows one of these to actually run. And the else if will help you solve this problem. Okay, let's go back to the PowerPoints here real quick. and then we're going to get into logical operators eventually coming up to solve this issue. Okay, so not only is the direction that your code flows and the order of operations that you do things in important when it comes to control structures, but then the other different forms of those control structures can be implemented, such as the if, else if type structure. And then there's the other example of a switch statement that you'll be looking at later on in the chapter for your reading. So often what we'll find when we are working within programming and if statements is needing to look at a value and setting a flag to see if a specific condition exists. And so an example of this would be, hey, I want to know whether valid months, if the months are valid. And that means, hey, this is be like an input validation thing where, hey, we're going to look at months. Did the user actually input months with a number greater than 0? And if they did, then that means that if months is less than 0, if they input months as less than 0, then they didn't enter in a valid month value. And so we use this as kind of a sentinel or a flag and say, hey, did the user enter in months correctly? If they didn't, then let's set a Boolean and say, hey, it's false. There's a problem here. And then when we go to do our processing, we can check the user's input. Did they enter in a valid month? If they entered in a valid month, let's go ahead and process the payment of total divided by months, because months is obviously a non-negative number because we checked it here. And so this is an example of a sentinel or a flag. You can also use flags, integer flags, just anything to set. You could set a value to any kind of variable to denote that an if statement did trigger. And that's one thing, one way of working with if statements. And then we get into your if-else statements. So let's go ahead and go back to our example code. And we get into the if-else structure. Okay, and it looks like this. So we have an if statement. Hey, is score greater than 90? If it is, output the grade. Else, see out not an A. I guess not an A. Okay, I guess that's fine. So what with an if else, what ends up going on is if this relational expression is evaluated as true, then that code is completed. Otherwise, this code is completed. So it's a this or that type of control structure. So let's go ahead and demonstrate that. Okay, I got my debugger set. The score is 91. I go in there, line 18, saw it as true, went into line 20, but look at what happens. It's going to skip over line 24. It's not going to do the else. So it's a this or that type of behavior. So it goes right to the end of the program, and this never even got. The else statement never even ran. So now let's change it so that this comes out as a false. So now the score is no longer greater than 90. It's 90, which isn't greater than 90. So now instead of the if statement actually running, it's going to complete your else statement here with line 24. So go ahead and run that in the debugger. Step over. Hey, is score greater than 90? No, it's not. That's going to Oh, here's a little cool thing that you do with a debugger. If you don't know kind of something is going to be evaluated at, you can actually select the whole evaluation, right click on it, and say add watch, or just hover over your selection. And you see I did an add watch there for this. And in my debugging window down here, I see score greater than 90 evaluates as false. So you can actually use your debugger to evaluate code for you as you're debugging. So this is going to be as false. So what's going to happen is the else statement is going to go to and be evaluated. Line 24. And then the program's done running. And so what you have then is you get your if and your else structure. But then you can have other structures, such as, or other types of if-else statements, and that is the if-else structure. And that means that only one, and this is very similar to your switch statements. Else if score is greater than, let's see, 60. You know what? If it's greater than 90, it's an A. If score is greater than 80, else if score is greater than 80, it's going to be a B. Okay, now let's look at how this one actually behaves. Else, see out, none. Whatever, yeah. So this is going to be, we're going to use this to look at our score range for our letter grade, depending on, you know, some kind of test score. And if our score is greater than 90, then we have an A. And once this is triggered, it no longer looks at this or this. Because in if, else if, else if, else if, else if, they can keep going. Else if. And you want to have your if, your else if, and then your else. This does a complete else if control structure. And of course you can add more else ifs in here if you wish. Such as, what about this one? Else if score is greater than 70. And then we'll do a C out C. Okay. Now remember, if I only have one line in there, I don't need to put my braces. And when we look at this, we're set score to 90, and it's going to fail the first one. But then it's going to check the next one and pass that one. So let's go ahead and test this one out. Okay. Step over. Score is greater than 90. It is not. It fails. It goes into scores greater than 80. It is true. Now here's the thing is once it's done running and it's found an associated control structure or an if statement that it matches with, it will no longer look any further in the else if control structure. Once it finds a true spot, it'll come out of the whole thing and be done with it. So then we look at that, hey, it's a B, then we're done. And so that's what the else type control structures does, is it allows you to have just one of these guys implemented versus all of them if you were just do if. Okay, so we've talked about this if else statements. I've already gone through this with you. So let's get into some of the other stuff that I wanted to talk to you about. And that is logical operators. But before we do that, no, actually, let's get into it. We've already kind of done the menu-driven programs you guys can do on your own. Nested if statements, again, look at it on your own. What I want to do is I want to get into these guys. These are the more important aspects of what you're working with, and that is your logical operators with your relational operators. Because the way that this code is written is not very good. And what we want to do is we want to make sure that this is specifically not looking at anything for an A other than what's between 91 and 100. And the way we could do that is with what we call a relational or a logical operator. And a logical operator is behaves like so. Okay, so when we are doing when we're doing an or and the and, so the or and the and is pretty much what the logical operators do. So here's an example of using a logical operator with relational expressions. We look to see is x greater than y, and then we look to see if y is greater than z. So let's get into this one a little bit more, because this is actually a good example, and let's play with it. Okay. So we're gonna go ahead and just go up to here, and I'm gonna pipe that in there, and we're gonna say if x is greater than y, and then we want to surround that with parentheses. Then we say and let's say z is less than y. And we're going to surround that with parentheses. And then we're going to look at how this actually behaves. Because when you look at the operator precedence and associativity of these operations, the relational operations have higher precedence and associativity than the logical operators, or and. So these guys are actually going to be evaluated first. And then the logical operator is evaluated. So the way this is evaluated is we look at x is greater than y. Hey, is x greater than y? X is 12, y is 5. So yes, that's a true. And then the z is evaluated. Hey, is z less than y? Yes, it is. So that returns a true. It is only then that your logical operator comes into play. And the way the logical operators work is based on a truth table. You can kind of think about with the and operator, the first has to be true, and any others with it have to be true for the whole if statement to be true. So what that means is with the truth table is 1 and 1 equals 1. Equals true. So a true and a true is a true. A false and a true is a false. A false and, or a true and a false is a false. A false and a false is a false. So then once we get into here and we know that the first one evaluates as 1 and the second one evaluates as true, and we look at our truth table for the and logical operators, a 1 and a 1 is true. So therefore that whole if statement evaluates as true. And you can continue on with that type of statement with more than just that. You could do things like and you can add more. And x is less than 6. And y is less than 3. Okay, so how is this all going to evaluate? Well, since these relational expressions all have, all of them from the first examples that I showed you, have left to right associativity, that means that these guys have the same precedence and associativity. So let's go ahead and back this up and let's finish it. X is greater than 2 and y is less than 9 or 1. Okay, that's fine. Okay, so this is a pretty significant if statement now, and there's a lot going on, and we know that the logical operators are going to happen last. We know the relational operators are going to happen first based on the operator precedence and associativity chart. So if they have the same precedence, then they're going to be evaluated from left to right. So the first thing that's going to happen is x greater than 3. No, that's going to return a false. Then we go look at, hey, is y less than 1? Yes. Oh, no, y is 5. That's a false. Then is x less than 6? X is not less than 6. That's a false. Is y less than 3? No, that's a false. So that comes out as a false. Okay, then the logical operators are done. And they have, if you were to stick an or in here, then you would have a different precedence. But since the logical and all has the same precedence, they're evaluated from left to right. So the first thing is done is 0 and 0. What is 0 and 0? 0 and 0 is 0. Then we go and we look at these ones. What is 0 and 0? Well, it's 0. And then we go look at this one. What is 0 and 0? Well, it's 0. And then that evaluates as a false statement. So let's get in. Let's do another one. Let's do this one. I'm just going to throw stuff out there. X is greater than 5 and y is less than 10 and z is less than y. Okay, so how is this evaluated now? Well, relational expression is done first. Is x greater than 5? Yes, that's a 1. Is y less than 10? Yes, that's a 1. Is z less than y? Yes, that's a 1. So then 1 and 1 is a 1, and then 1 and 1 is a 1. Oh, cool. That evaluates as true. And that is kind of the way the and works. So basically, when you have different relational expressions, this has to be true and that has to be true for this whole sub part to be true. And then you take the answer from this and you add it with whatever else is in there. And that's called cascading. It's cascading operations. We get into the next logical operator where things are going to get a little bit more complex. And that is when we do the or. And this is the main thing that I want to talk about today. I don't want to spend too much time because I want to go in and play. So we're going to go in and do an assignment here soon. After I get done talking to you about the or logical expressions. So the truth table for the or is 1 or 1 equals 1. So basically it's like this has to be true or that has to be true for the whole thing to be true. 1 or 0 equals 1. So as long as 1 is true, the whole thing becomes true. 0 or 1 equals 1. And then, of course, 0 or 0 equals 0. So you see kind of how it's an inverse of the and. It's kind of an inverse of it. You got 1, 0, 0, 0, then you got 1, 1, 1, 0. So the or, the and means they all have to be true for the whole thing to be true. But when you put in an or, that means only one has to be true. So let's look at how that changes things. Let's put in the or, and that's the two pipes here. So is z less than y? Let's look at, is x greater than 5? X is greater than 5. That's a true. Y is less than 10. Oh, but I'm missing something. I'm stepping. I need to look at my operator precedence and associativity here, because I don't know what happens first, the and or the or. Let's make a few changes. I want to put in some other numbers in here. Let's say if X is less than 5, just to give you a little bit more variety, and X is less than 10. Cool. All right. First, what happens before operator precedence and associativity? In fact, let's just look at what that is. So let's go, and bank charges is what we're going to be doing here. C++, operator precedence, and associativity. Okay. So when we look at the chart, we'll see that our logical operators, here they are. You'll see that where's our and our ors? Did they even put them in this chart? Bunch of silly gooses. Those are all relational. Here it is. Okay, so you see here that our relational operators have higher precedence than the and or the or logical operators. That's why I'm doing those first. And then we also see that the ampersand has higher precedence than the or. So that's what's going to happen, and the or is not going to happen until last. So let's do the highest precedence, which is what the heck happened there? Okay, highest precedence, which is our relational operators, is X less than 5. Well, X is 12, so X is not less than 5. So this is going to evaluate as 0 or false. X is not less than 5. Then we're going to do this next one. Hey, is Y less than 10? Yes, it is. That's going to evaluate as true. Then this one is going to happen. Hey, is Z less than Y? Yes, it is. That becomes true. Now we look at our precedence and associativity chart, and the next operators that we have are the ampersand and the or, and we saw that the ampersand actually has a higher precedence than the or. So this one is actually done first. So then I'm going to say, hey, what's 0 and 1? Well, 0 and 1 is 0. So that's going to come out as 0. Then we look at our last logical operator, 0 or 1. Well, 0 or 1 is a true, because remember, only one has to come out as true. So that's going to evaluate as true, which means the whole if statement is true. Okay, so these concepts are the main important part of this whole chapter, is understanding how those control structures are broken down, because they're not your last control structures you're going to be learning about. You're going to be looking at learning about loops here soon, for loops and while loops that are also control structures that change the way your application actually moves and is evaluated. Okay. That takes us back into our goal for today. I wanted to get the logical operators done. And then I wanted to get into show you a little bit on debugging. We did that. And the last thing I want to do is show you, get you started on one of your assignments. Now, this is just going to be the demo. And so I think what I'm going to do is I'm just going to set you up for this one. So that means that you can actually finish it up for your assignment. So what we're going to do is let's look at the actual assignment that I'm talking about, and then we'll get started on it. And you guys, make sure you write that truth table down. It's everywhere. If you take logic, and this truth table is a universal thing for many different disciplines than just computer science. Okay, so our assignment is bank charges. And bank charges that we're working on is right here. And what I'm going to do is I'm going to just do the first two. I'm going to just do the first two, and then I'm going to let you guys finish the last two for the actual code to finish it up. But let's deal with input, process, and output. So let's come back to that in a second. I'm going to take a small break, and I'll be right back. Okay, we're back. All right, so the problem that we're going to be doing is called bank charges. And what we want to do is we want to do our IPO chart. Just get used to doing it as you're learning. That's where your start is. And so what we're going to do is we're going to do input, process, output. So our input will be for a $15 charge per month plus the check fees for commercial checking account. So essentially, we want to display the bank fees for our month. So our input is going to be how many checks were written. That seems pretty simple. So let's go to our program and let's get that one written down. So our input is how many checks? How many checks? Our process is going to be if statements, if statement, if statement with logical operators. And our output is going to be the fee. Okay, so let's do our input, and let's decide on a data type that I want to store my checks, the amount of checks I have. And since you can't have half a check, that's an integer number, and we'll just call it checks. No, let's be a little bit. N checks for number of checks. And well, let's assign that to 0 like we should. Then we're going to ask the user, hey, enter how many checks you wrote. And then we're going to do our CN of in checks. CN n checks. Number of checks. Okay, so the number of checks. Okay, now you're learning. So this is where I would do a C out number of checks and make sure that we actually got it as you're learning. And don't write more than 1 line or 2 lines of code without things working, guys. Seriously, you don't want to write a whole program and then try to get it to work. It's wasteful for time. Check as you go. Write 1 line of code and make sure it works, and then move along. Okay, so I'm going to just check that I have my memory. Get your memory, print your memory. I'm going to say I wrote 23 checks. Okay, 23. We're good. Now we can start designing our if statement. So then let's look at our if statements. Let's look at our solution, our problem, and saying, hey, they're 10 cents each if the checks are fewer than 20 checks. But they're 8 cents each if the checks are between 20 and 39 checks. 6 inches each for checks that are 40 to 59 checks. So what we want is to process based on any of these 4 outcomes. And that means that we need to have an else, if, else type of construct or control structure, but we also need logical operators because we have a range. We have to say, hey, if number of checks is greater than 20 and number of checks is less than 39. So these first 2 I'm going to set up for you. And then I want you to finish the last 2 on your own, if you're following along, and you can get that done and submit it for your assignment. So let's start with the first if statement, and just begin, because we may be modifying as we go, but also let's think about what order should these happen in. And it seems to me that we could basically look to see if the number of checks is greater than 19. If it's greater than 19, then they're 10 cents each. That's an easy one. So let's go ahead and put that in there. So let's say if, and you know what? Let's go ahead and process it while we're at it and just have an answer for just this one. So remember, let's just write code, get it to work, and just one bit at a time. Okay, so let's just check and let's just get this one working. So we're going to say, hey, if, and what's my relation? If the number of checks is fewer than 20, less than 20. Then, if that is true, then here's my processing. My fee, oh, now we got some money. So this is going to be a special variable called a float. You can make it a double if you wish. They're both floating point numbers. Float just uses up less memory. Fee. And then we're going to assign that equal to 0.0. Don't assign it equal to 0 and force an implicit conversion. There's no reason for that. Assign it to 0.0 appropriately, please. Okay, now we get the number of checks, and then from those number of checks, we can calculate the fee because the fee is based on 10 cents each. So we can just say, hey, fee equals, and it looks like it's going to be 0.10 times number of checks. Okay? And you guys can do the IO manip to get it outputting as money. You guys learned that from last chapter. I'm not going to do that. So now that we've done with our control structure, we got our input. We have our process, just the initial, one of the initial processes. And then we're going to have our output. Cout your fee for the month is, and then this is where we will inject in the next output that we want, which is I'm going to put a space there, which is just going to be fee. And this is where you would put your IO manip to output it as dollars. It'll put the dollar sign in there for you, and you can do a fixed point of 2 in currency for that. So looking at your IO manip from last chapter for getting that to output as money. Okay, so let's just test this and make sure that it's working. And I'm going to go ahead and do a breakpoint. And we're going to run it. And I'm going to say, hey, I'm going to step over now so that it outputs, because right now it's not run that line. So I'm going to step over. I don't think that is actually the one I'm running. This is the one I'm running. This one was a previous run. I got to shut that one down. So right now it's not done anything. It's just kind of running. I'm going to do a step over, and then it's going to say, hey, how many checks do you want? So bring up, there it is. How many checks do you want? So now the CN is going to run, but I need to do a step over before I put the number in so that it's expecting it. So I'm going to do a step over here. Oh, wait, no. I'm going to put the number in and then do a step over. So what we want is, let's just test this with 12. Oh, no, I got to do a step over and then put the number in. Okay, so step over. Then I'm going to go back here. There we go. 112? No, let's just do 12. Okay, so that's 12 checks. And then my runtime goes back to the if statement. And hey, is the number of checks less than 20? Yes, it's 12. So now it's going to go in here, hey, fee is equal to 10 cents times number of checks. And we can even hover over. Fee is right now 0.0. I do another step over. Now fee is 1.2. It's $1.20. So it's going to output all of that without showing it as $1.20 like it should. I want you guys to fix that. Do your IO manip stuff for that. And that is completed. So now we go into the more difficult one, which is where we get the operator, the logical and to work. And that is going to be done with an else if. Now let's put our default else in there. And what this is going to be is just to be out, see out something is wrong. Essentially, that means that the user didn't put in a number of checks. They didn't enter the number of checks correctly. They may put in a negative number. In fact, I think what we should do is let's do a nested if statement here. And we're going to say, hey, if n checks is greater than 0, and only if the number of checks is greater than 0, should we do our processing. So we're going to nest it all the way over to here. For that if statement. So now, only if the user has properly entered in the number of checks, and so we've kind of curtailed a little bit on this issue right here for this something is wrong error. Something else could have a problem where one of them in your control structure, one of these wouldn't be actually hit upon. But what we want to look at is, let's look at now the 8th. So if you do 20 to 39 checks, then they're 8 cents each. So else if number of checks. So what we're doing is we need to do I believe we need to do an or, but let's get into it. Oh no, it's going to be an and, because we need to see if number of checks is greater than 19 and less than number of checks is greater than 19. That means 20 checks. And if number of checks is also less than 59, so that'd be 60. So this is going to be checked, but they have to both be true for the whole thing to be true. So number of checks has to fall in that range of 20 to 59. And if number of checks falls into that range of 20 to 59, then this if statement is going to be run. And that's when we just take, oh, well, I already wrote it. And this is where I want to really tell you, start small, because after a while, it begins to snowball. And before you know it, you're just copying and pasting. You're like, oh, how do I even begin? Well, start small. And before you know it, copy paste comes into act, and you're rolling along. So instead of 10 cents a check, it's 8 cents a check. Done! Wonderful. Okay, now let's test it. So I'm going to enter in 25 this time. And what I'm going to do is I'm going to stop it here after I've entered in the number. Okay, and let's say that we wrote 25 checks. Okay, now is n checks greater than 0? Yes, it's 25. And notice how all these if statements, all this is inside of this one nested if statement. So that it solves it goes beyond our first error checker. And hey, is number of checks less than 20? No, it's not. Now, is number of checks greater than 19? And is number of checks also less than 60? Yes, it is. There's our fee. And remember and notice that this else is not going to be hit because nothing went wrong. We're doing good. Okay, our calculation is done. We come back and we output our fee. And here is our answer. $2. So and again, you guys make sure you put your dollar sign in there to output it as money. So what you're going to do is you're going to add some more else ifs in here. You're going to add another 2 else ifs, I believe another 2 else ifs for this outcome, another 2 else ifs for the other outcomes that I have not described. So you're going to finish up those 2 for this particular assignment, and then you can turn that in. Okay, so the main part about this is how those relational operators and logical operators work. And here's why they're important, is because it's how control structures are controlled. That's what we call them, control structures, is because we control them, and they also control how our mechanical flow, the flow of our program. It's all about the flow of your program and where it goes and what it does. And that flow always starts top down, line by line. All right, guys, thank you.